Welcome to Maths class with AJ Tutoring Specialists and this video on solving quadratic equations part 2. This lesson builds directly on part 1 where we focused on the process of completing the square to rewrite quadratic expressions. It is important that you have watched the previous video first. Our learning intention is to solve quadratic equations by completing the square. We will do this through 3 levels of difficulty. We will begin with level green, solving simple quadratic equations where the coefficient of x squared is 1. In level yellow, we will work with equations that require rearranging and factoring before completing the square. For level red, we will tackle more challenging equations with non-unit coefficients. In this lesson you will need 1. A laptop or tablet, 2. A pencil case, 3. A work booklet, an exercise book or paper. Solving quadratic equations by completing the square. Let's begin with our lesson by looking at the reasons on why we need to complete the square. Not all monic trinomials can be solved by factorizing. In these cases, completing the square provides a reliable method that will always rewrite a quadratic equation into turning point, vertex, form, allowing the equation to be solved systematically. Using the method of completing the square, the solutions to a monic or non-monic quadratic equation may be 1. Rational, where the solutions which are x-intercepts are in the form of whole numbers or fractions that are terminating or repeating. 2. Irrational, solutions that are non-terminating, non-repeating numbers involving surds, such as square root 2 or pi. 3. Have no real solutions, where the graph has no x-intercepts. While completing the square is a powerful and universal technique, the trade-off is that it can be more algebraically demanding than the factorizing method. In our first example, we will focus on solving a monic quadratic equation by completing the square. We will apply this method step by step to solve the quadratic equation x squared minus 4x minus 12 equals 0. Step 1. Halve the coefficient of x. Square it. Add and subtract this value to the left side of the equation. Minus 4 divided by 2 equals minus 2 and minus 2 squared equals 4. That is x squared minus 4x plus 4 minus 12 equals 0. Step 2. Factorize the newly created perfect square x squared minus 4x plus 4 and collecting the constant terms gives us x minus 2 squared minus 16 equals 0. The result from step 2 is called a difference of two squares. Step 3. Factorize the newly created difference of two squares to give x plus 2 times x minus 6 equals 0, which are known as linear factors. Step 4. Solve for x using null factor law. That is x plus 2 equals 0 or x minus 6 equals 0, which give x equals minus 2 or x equals 6. Express answer in set notation. Solutions are x is an element of minus 2 and 6, which are our x-intercepts. Let's practice to build your confidence. It's your turn. Feel free to pause the video and attempt the next 4 examples starting with level difficulty green. Also, the step-by-step solution of the worked example is on the left-hand side for you to refer to while attempting the 4 examples. Do not forget to resume the video to confirm your solutions. It is time to consolidate what you have learned. Hopefully by having practiced with the 4 examples you should be confident enough to attempt either all of the 3 level questions or just one level that you are comfortable with. How did you go? If you did not get the correct solutions, then it would be useful to go back through the examples before proceeding to the next section. However, if you managed to get most or all questions correct, then continue with the lesson on to the next section. In the next section we will look at solving non-monic quadratic equations by completing the square. As we have seen previously, using appropriate algebraic techniques, all quadratic equations can be rearranged into the standard form a times x squared plus bx plus c equals 0. When the coefficient, a, is not a factor of both b and c, the quadratic cannot be solved using monic factorization. In such cases, factorizing into 2 linear factors is not straightforward or may not be possible. For example, the equations 6x squared minus 12x minus 5 equals 0 and 4x squared plus 8x minus 3 equals 0 cannot be factorized using monic factorization. In situations like these, completing the square provides a systematic method to rewrite the quadratic into a perfect square form, allowing the equation to be solved accurately and consistently. Let's go through step by step in solving the following non-monic quadratic equation 6x squared minus x minus 1 equals 0 by completing the square. Step 1. Divide the equation through by the coefficient of x squared to give x squared minus 1 over 6 times x minus 1 over 6 equals 0. Step 2. Halve the coefficient of x. Square it. Add and subtract this value to the left side of the equation to give x squared minus 1 over 6 times x plus 1 over 144 minus 1 over 144 minus 24 over 144 equals 0. Step 3. We then factorize the newly created perfect square x squared minus 1 over 6 times x plus 1 over 144 and collecting the constant terms to get x minus 1 over 12 all squared minus 25 over 144 equals 0. We then factorize this difference of 2 squares to give x minus 1 over 12 plus 5 over 12 times x minus 1 over 12 minus 5 over 12 equals 0. Step 4. Solve using null factor law. We assign each linear factors equal to 0 and solving for x. That is x plus 1 over 3 times x minus 1 over 2 equals 0. Finally express answer in set notation. Hence the solutions which are the x-intercepts are x equals minus 1 over 3 and 1 over 2 respectively. It is time to practice. Feel free to pause the video and have a go at the next 2 examples on solving non-monic quadratic equations. The step-by-step solution of our first example is on the left-hand side for you to refer to as you attempt the next 2 examples. Finally, do not forget to resume the video to confirm your solutions. This section looks at solving quadratic equations with irrational solutions. In many cases, although a quadratic equation can be solved, the solution set may contain irrational numbers. Examples of irrational numbers include square root 7, square root 5 over 3 and square root of 11 over 5. The method used to solve these quadratic equations remains the same. However, an additional level of complexity arises when interpreting and simplifying the solutions. Care must be taken when working with surds to ensure the final answers are expressed accurately and in their simplest exact form. Let's go through step by step in solving the following monic quadratic equation x squared plus 6x plus 2 equals 0 by completing the square with irrational solutions. Step 1. Halve the coefficient of x. Square it. Add and subtract this value to the left side of the equation. That is x squared plus 6x plus 9 minus 9 plus 2 equals 0. Step 2. Factorize the perfect square to give difference of two squares, x plus 3 squared minus 7 equals 0. Step 3. Factorize the difference of two squares. Taking note of the newly created irrational number, that is x plus 3 plus square root 7 times x plus 3 square root 7 equals 0. Step 4. Solve for x using null factor law by assigning two linear factors to equal to 0. Express answer in set notation. Hence the solutions or x-intercepts are x is an element of minus 3 minus square root 7 and minus 3 plus square root 7 respectively. It is your turn now to have a go and work through the next 3 examples. Feel free to pause and resume the video to attempt and confirm your solution. For our final section of this video, we are going to look at quadratics with no real solutions. That is, there are no x-intercepts. In some cases, a quadratic equation cannot be solved within the set of real numbers, even when using completing the square. This occurs when the equation has no real solutions. For example, the equation x squared plus 9 equals 0 has no real solutions because x squared is always non-negative for all real values of x, and therefore cannot equal minus 9. It is important to note that solutions do still exist. However, they are not real numbers. For this reason, it is correct to state that the equation has no real solutions, rather than saying it has no solutions. Let's solve the following monic quadratic equation x squared minus 6x plus 18 equals 0 by completing the square with no real solutions. Step 1. Halve the coefficient of x. Square it. Add and subtract this value to the left side of the equation. Step 2. Factorize the newly created perfect square. Step 3. Check if the constant added to the perfect square is positive or negative. Step 4. If the constant is positive, state that there are no real solutions. Hence, since constant is positive, there are no real solutions. For the remaining of this video, there are 3 examples for you to work through and practice for solving quadratic equations with no real solutions. This is followed with an exam-type multiple-choice question to provide feedback on your understanding. Then finally 3 levels of difficulty questions for you to consolidate your understanding. Thank you for watching this video on completing the square. I hope you found the lesson clear and helpful in strengthening your understanding of solving quadratic equations. If this video was useful, Please don't forget to subscribe to the channel to help my channel grow and to stay updated with more high-quality mathematics lessons from AJ Tutoring Specialists. Your support is greatly appreciated. I will see you in the next video.